So notice we have the light on the top right. To create the rim light, I will copy this light and position it below the volume, pointing upwards. So again, what I'm going to do is create the light and position it through the viewport. So under the camera menu, look for the look through light menu and select aerial light 1. Now again, I will control click the aerial light to create a second light. Again, I will lock the light to the current view and orbit until the light is below the volume and to the left. So let's try with this. Now I will change the name of the lights just to be sure that we don't get confused later on. I will call this key light. The second light I will call rim light. Now let's make sure to turn off lock to view. This way we don't accidentally move the lights or the cameras. And go back to our camera view. Now let's go back to our render view and press render. Okay, so somehow I managed to change the exposure to -3. This is why I'm not getting the rim light here. I will increase this to 4. And now we'll start getting this rim on the bottom left side of the volume. So although this is looking very nice, I still want to increase the contrast of the rim light. So this can be achieved in several ways. I could select the light and increase the exposure. Another way to achieve this, which is also common in product photography, I could bring the light closer to the volume to get a higher exposure here. So let's do that. I'll go back to my scene view. I will push back. And I will bring the rim light closer to the volume. Let's go back to our render view. And I think we're getting there. So one last thing I want to tweak is I don't really like these very dark shadows. And to address this, I will add a third light. It could be another area light, but in this case, I will use an environment light with a very low exposure. So I can do that even from the render view. I will press Control click on the environment light. I will change the light intensity to 0.25. And again, take a look at the render. So notice how these very dark shadows are washing away. Of course, if I increase this drastically, we will have much less of those darker shadows. But I will definitely go with a lower value. So I think 0.5 can work. I think I will also increase slightly the density of the volume. So let's do that now. Remember, you can press 3 to go to the material context. Select your shader. And let's try increasing the density to 750. Okay, so I think this will do. Another thing that I noticed on the references is that since usually the camera is very close to the water tank, you will get a very nice shallow depth of field. And what this means for a render is that you will usually have a very defined area where you're focusing the camera, but behind and in front of that area, you will usually have some blurriness or some defocus. So what I'm going to do now is try to achieve this sense of defocus using the camera. And the first thing we need to do is determine the distance between our camera's lens and the actual volume. So let's go to the scene view, press spacebar 2 to go to the top view, and notice how the camera is slightly behind the 1 meter distance. So let's select the camera. You can press S, then select the camera, and let's take a look at the transforms. So I'm interested in the Z distance. So the Z position is 1.1. This is the value that I will use to set the focus of the camera. So I will copy this value, Control C. I will go to the Sampling tab, and here under Focus Distance, I will paste this value. Of course, you can also channel reference the transform from here. So let's do that. I will right-click on the Z position, copy this value, go back to Sampling, right-click on the Focus Distance, and paste as a relative reference. That way, if I move the camera closer or further away, this focus distance will change accordingly. Now, there are a few things that will determine the amount of defocus that the camera will have once a picture is taken, or in this case, once the render is created. And the main factors are the shutter time, the f-stop, and the distance from the camera to the objective. Since in this case we already have the camera in its proper place, I will use the f-stop to control the amount of defocus of the image. So let's go back to the render view. Let's decrease the f-stop. So the lower this value is, the greater the defocus will be. So let's try exaggerating this value. Let's go with 0.1 and let's try to render again. So you may notice nothing has really happened. So we need to also tell Mantra to take into consideration the defocus of the camera. So let's go back to the output context. You can press 4, select your Mantra node, and under the rendering tab, look for the enable depth of field property. This toggle needs to be turned on. Okay, so now you can see a huge change on the image. Notice how these parts of the volume that are closer to the camera will have a huge defocus. Same for the parts of the volume that are behind the focus plane. So of course I'm hugely exaggerating this value just for you to see the difference, but I think I will go back to my camera and I will increase the f-stop just to have a bit less of the focus. I want this effect to be quite subtle. So I can probably go higher. Let's try with 2. And again, as most of the parameters on these tutorials, I will leave up to you and to set to your own taste. Okay, so in terms of the lighting and the defocus, I think I'm happy with this. I will probably increase the exposure for the rim light. So I will select this rim light, increase the exposure. Let's try with 5. I can even go higher. I'll try with 6.5. So I want a very nice and contrasty image. Let's try with 6. And I think I'll go with this. So let's go back to our output context. You can press the 4 key, select your Mantra node, and let's take a look at the properties just to make sure that we have a nice quality once we render. So first of all, let's take a look at the pixel samples. What I usually do is just test with a very low value. So 3 samples is quite low for a final render. What I will do is increase this to 6 samples. And depending on the time you have to render, you might even increase this to 8. What I would suggest is render a complete frame and calculate how long the full frame range would take. So we can do that now. I'll go to the last frame of the animation. I will also turn off the gradual refinement. This way Mantra will render the full frame with full quality. And here you can see more or less the time that it will take to finish this frame. And back to the Mantra properties, there's 2 more things that I want to make sure I have set correctly. First of all, the valid frame range needs to be the entire sequence. By default, the Mantra ROP will use the current frame only. So make sure to change this to render frame range. One more very important thing you want to check is the name and the folder where the file will be saved. So go to Images, Output Picture, And here you can either leave the default name or change the folder where those frames will be stored. In my case, I will change the folder. Instead of hip name, I will use $OS. So the resulting folder will have the name of this node, in this case ink, and the name of the file will be OS $F4, meaning the name of the node and a number padding. So one final note, make sure you save this file as an EXR. This will generate a high quality file with an alpha channel embedded, which we will need for the final composite. So for now, I will render to disk and come back once the frames have finished rendering.